table is actually going to directly relate to next unit. Next unit, we're going to have one set of naming rules for your representative elements, these. You're going to have another set of naming rules for your transition metals. And then your inner transition metals we pretty much don't really use at all because they are the F block on the periodic table. So looking at your representative elements, these are the elements in the S block and the P block on the periodic table. With your S block and your P block on the periodic table, these have a set number, usually, of valence electrons. And with the set number of valence electrons, they're going to give us a set naming rule that we're going to use when we are looking at those elements themselves. So when we look at the S block and the P block on the periodic table, those are called representative elements. Now the next type is called a transition metal, and that's the D block. With your D block on the periodic table, you have the electrons further inside of the atom. Remember, they jump in one energy level. So because of that, they actually lose different numbers of electrons. They don't have a set number of valence electrons that they always are going to lose. So these are going to have a different set of naming rules, and they're called transition metals. The last type are called inner transition metals. These are the valence electrons that actually hide two levels inside of the atom. So instead of being valence shell, the transition metals jump in one energy level, the inner transition metals jump in two energy levels. So when we look at the periodic table itself, I'm going to switch over to my document camera here. I have a periodic table that I kind of colored out, and it looks at the different kind of like zones on the periodic table. But your representative elements, your S block and your P block, are all in pink. These have a set number of valence electrons that we're going to look at here in a second. Transition metals are what I have in green. Those transition metals have different numbers of valence electrons that they're going to end up losing. They're all going to lose electrons, but they're not set in stone. And then down here at the bottom we have the inner transition metals. These electrons jump in two energy levels. Again, we're not really going to do anything with these pretty much all year long till we get to the nuclear unit. But these are called inner transition metals down here. Now what the representative elements do for us is we can look at the number of valence electrons that are there. They always have a set number of valence electrons. So in your notes, with your valence electrons, remember it's the electrons in the outermost energy level. And with those electrons in the outermost energy level, because of the modern atomic theory where you have the D block and the F block jumping inside of the atom, your magic number is 8 valence electrons. And with those 8 valence electrons, nothing on the periodic table has more than 8. Everything in group number 1 all have 1 valence electron. Everything in group 2 has 2, 13 has 3, so it's everything that we talked about last unit, but it has to do with those representative elements. So I'm going to take my periodic table, if you want to use the one that you colored or your main one that you're using day to day, and we look at that one. This is just a blank one, but I have the periodic table here, and with your valence electrons, everything in group number 1 all have 1 valence electron. Group number 2 all have 2 valence electrons. Group number 13 down here, I skipped all of these groups 3 through 12 because those are transition metals. Group number 13 all have 3 valence electrons. 14 is 4, 15 is 5, 16 is 6, 17 is 7. Now with your noble gases down here, helium, if we draw the Bohr model for that one, there's only 2 electrons in helium. With the Bohr model, you put the dot in the middle, there's only 2 electrons that can fit in that first ring, but it only has 2 electrons. That's a full valence shell. Helium only has 2 valence electrons. Everything else down below helium all have 8 valence electrons. They have full valence shells. So the D block, the transition metals, and the inner transition metals, they don't have a set number of valence electrons. So when we're talking about like the families next unit, when we talk about the alkali metals, not next unit, this unit, sorry, the alkali metals all have 1 valence electron. The alkaline earth metals all have 2 valence electrons. The noble gases we just said had full valence shells. The full valence shells is 2 or 8 because those get split. And then your halogens all have 7. So with the predictable characteristics, a lot of it has to do with these valence electrons and how many they have and how close they are to having a full valence shell.